All right, hi everyone. Good morning. Wish you guys a very happy new year. Yeah, hi Tanmay. Good morning, Meenakshi. Good morning, Prakash. Hi Smriti. Good morning, Anjali. Good morning, Avni. Yeah, hi Aravir. Yes, wish you guys a great year ahead. This year is important for you guys. Board exams का year है. All which you have been anticipating since a long time. Finally, like some days back only they announced the dates also for CBSE. I think ICSE का पहले ही announce हो चुका था. अच्छा, ICSE का अभी तक announce नहीं हुआ है क्या? What are the dates? Okay. Tentatively तो वो लोग भी मे में ही रखेंगे. I'm sure that it's not going to be uh, much different. But yeah, CBSE ने set कर दिया है, तो mostly other boards will also follow it. राइट राइट. तो अकॉर्डिंगली आई थिंक अब आप लोगों के स्कूल के प्री बोर्ड्स भी शिफ्ट हो गए हैं, और आर द प्री बोर्ड्स अलोंग द सेम शेड्यूल? अच्छा, some schools have taken that into account, whereas some schools में अभी भी ओल्डर शेड्यूल ही फॉलो हो रहा है. ओके. तो हो सकता है फिर अभी एक प्रीलिम्स वो अभी कराएं, एंड देन उसके बाद इट विल बी अ प्रीलिम्स राउंड 2, और सॉरी प्री बोर्ड्स राउंड 2. दैट माइट हैपन. बट ठीक है, at least some relief to students. They have now a certainty, a target date in mind, that ab tak they will have to prepare and make sure that all things are in place. So good. All right, so I think most of the students have joined in. I think some students are still on their way. कोई कोई अभी उठ रहा है, कोई फिगर आउट कर रहा है कि शुड आई ब्रश बिफोर द क्लास और नॉट. Someone is like गेटिंग स्कूल्डेड बाय पेरेंट्स कि हाँ तुम 8 बजे की क्लास के लिए 8 बजे ही उठो. हाँ, आप लोगों का आई थिंक यू गाइज आई होप हैव ऑल रिसीव्ड द अनाउंसमेंट्स दैट टिल वैलेंटाइंस डे February 14 तक we will have our classes, and post that then you guys will thoroughly focus on your board examinations, and once your board examinations get done, then your JE classes or your NEET classes will begin ASAP. थोड़ा सा गैप मिलेगा आपको for a breather, but I don't think it will be a bigger breather. Post boards थोड़े से टाइम बाद क्लासेस स्टार्ट करेंगे. Then once some syllabus is completed, some chapters are done, then you guys will get another breather, another holiday of a good 15 to 20 days. I think generally that is the pattern. Will we be able to complete this chapter? That's a good question, Sharvin. Now, um, given the fact that आप लोगों का साथ में physics and maths भी रहता है, तो we will try to take this chapter to a conclusion where post your board examinations, resuming it will be a relatively easy task. Because getting it completed, I wouldn't promise it right up front, because we are doing it from the perspective of advanced. So we really need to get into the depth of it. For example, आपने जो last class में question देखा था फोटो इलेक्ट्रिक इफेक्ट वाला, जिसका solution भी मैंने आप लोगों को भेजा था, that's actually a previous JEE advanced question. So that question was something which was a good question, and for that, for you to be able to do those kind of questions, you really need to get into the depth, right? Okay, Arnav. So I have Arnav with me who's saying it as his first class uh, because of the examinations and all. So today we'll be starting with Bohr's model, Arnav. In fact, I hope most of the students have joined in. So let's start our discussion for the day without much delay. So we are going to focus on Bohr's model of atom. Now, as part of our earlier discussion, right, हम लोगों ने quantum theory of light and photoelectric effect discuss कर लिया है, and this was something that we discussed post Rutherford's model, right? So generally आप लोगों ने अपने junior classes में जब atomic structure पढ़ा था, so you would have come across this sequence in which you study Rutherford's model, and then post Rutherford's model you study Bohr's model. However, when I started discussing this chapter, before Bohr's model, I actually took you through the quantum theory of light, and the results are experiments associated with this. Now, नहीं Vedant, we will not be doing that heat capacities of solids at low temperature. So the reason why we went in this way is to help you understand that Bohr's model of atom is actually a combination of Rutherford's model plus quantum theory of light. Because if you look at the way in which Bohr's model is, in similar to Rutherford's model, you have a nucleus and an electron revolving around that nucleus, right? You remember this is what we had studied in Rutherford's model. That Rutherford model using gold foil scattering experiment suggested, as well as taking some inspiration from the planetary model of atom, a planetary model of solar system, that if we think about the atom, the nucleus is at the center with electrons revolving around it. And Bohr's model is also the same. Like Bohr's model also says the same thing, that nucleus is at the center and electrons revolve around it. However, Bohr's model comes as an improvement over Rutherford's model because it utilizes quantum theory of light, and it talks about the concept of quantization of energy. What do I mean by quantization of energy? That is what Bohr's model introduced, and we understand them as stationary orbits or shells or energy levels around the nucleus. So we are going to write this down in a more articulate manner, in a step-by-step bullet point manner. However, just wanted to give you a perspective that over and above Rutherford's model, what Bohr's model primarily did was introduced this concept of energy levels or orbits. And how do we visualize this? We visualize this in this simple manner that you have nucleus and electron can revolve around it. However, it cannot revolve around the nucleus randomly in any orbit. Like ऐसा कोई सा भी अपने मन से आप अपना ऑर्बिट नहीं चूज कर सकते. There are certain orbits only, certain allowed orbits, certain quantized energy levels only, in which the electrons can be present. Now, this concept was initially an on paper concept by Bohr. What do I mean by on paper? Like he had thought about it in a theoretical manner that this is what it should be. Now, does the scientific community accept things for as they are, or do they require any experimental evidence? Of course, they require experimental evidence, right? So, can anyone tell me how did Bohr provided evidence for his model? If you would have read across it, anyone, you can raise your hand. Okay, so I have Gaurav who has raised his hand. Tell me,
Sir,
Gaurav.
I'm not sure about this, but I think, sir, the experiment including the atomic spectrum, as in when we can take a metal with a low Hawk function and then strike it with light, and of light with different frequency above the threshold frequency, and because of that certain electrons will be emitted from certain shells. Like it depends upon the
Mm-hmm.
energy of the light, or the
Mm-hmm.
energy of the photon. uh,
Mm-hmm.
because of the wavelength, because of the frequency, the wavelength and frequency, the energy would be changing. So we, in the end, we would get different energy photons, and when different energy photons would strike on the metal plate, then there's a chance that different energy, for one photon there will be an electron ejected with different energy. Let's say if some
Like,
electron is excited to some particular state, as
हम्म.
soon as it de-excites, it will release a photon of some energy.
अच्छा अच्छा, थोड़ा सा अब हम एक डिटूर लेंगे. डिटूर नहीं लेंगे, इनफैक्ट let me highlight this over here, that Bohr's model of atom is valid for single electron system. What do I mean by this? Something like a hydrogen atom, या helium plus ion, या lithium 2 plus ion, right? Something like this, etc. So Bohr's model of atom की validity is on single electron system. It does not hold accurate. ठीक है, I would say accurate. It does provide important understanding, but it does not hold accurately for multi-electron system. जैसे फोटो इलेक्ट्रिक इफेक्ट में कोई मेटल आपने यूज किया, तो मेटल में तो कैसा है, न्यूक्लियस, न्यूक्लियस के अराउंड बहुत सारे इलेक्ट्रॉन्स, राइट. हाउएवर, टू स्टार्ट विद, Bohr's model of atom will be something which is for a single electron system. तो इसमें जो एनालिसिस किया जाता है, जो एक्सपेरिमेंटल एविडेंस भी ढूंढा जाता है, वो एक सिंगल इलेक्ट्रॉन सिस्टम यूज करके ही देखा जाता है. So rather than working with the, so you were right, Gaurav, to begin with, that we did use the experiment of atomic spectrum, but उस atomic spectrum का experiment was done on hydrogen. ठीक है, but हाँ, I would want to get a more articulate answer. बोलो देवांशी.
Oh, yes, sir. So, a Bohr's model, he focused on the location and the mode of rotation of the electrons around the nucleus. And as you said, it is valid for a single electron system. So, when he did it with the hydrogen gas, so then as long as the electrons they rotate in the energy levels or the energy shells, so it neither loses nor it absorbs any energy.
Mhm.
And when an electron is supplied energy,
Mhm.
it moves in the orbit of the higher energy. Every electron wants to move in the higher shell of the atom.
Mhm.
And when the electron is dropped back to the original orbit, the energy gets radiated by the atom And there's this equation E2 minus E1. So according to that, he said that like he spoke about the higher energy shell and the lower energy shell that way.
ठीक है, काफी close है, like really good. So let me build up on that. So what Bohr's model was an improvement over Rutherford's model is by introducing these energy levels. So as pointed out, we have nucleus, and nucleus ke around there are energy levels. Even hydrogen atom has energy levels. ऐसा नहीं है, ठीक है? This is a sort of a very big misconception among students that hydrogen has only one electron. That means it has only one shell or one energy level. ऐसा बिल्कुल भी नहीं है. Please listen to me very carefully. Around the nucleus, we have different energy levels that are present. Even for a hydrogen atom, like a single electron species, we have different energy levels around the nucleus. Some are lower energy levels, some are higher energy levels. In naturally occurring state, in naturally occurring hydrogen atom, we find the electron to be present in the lower energy state. Why is this lower? I will talk about it in a while. But in naturally occurring form, we find hydrogen in a lower energy level. However, what Bohr did was, in order to experimentally validate his theory of energy levels, he performed experiment in which he provided energy to these electrons, and he provided energy such that rather than coming out of the atom, right? That is one thing that we studied in photoelectric effect, that rather than coming out of the atom, he provided particular energies to these electrons so that they just jump to the higher energy levels. And when they jump to these higher energy levels, they can de-excite back to the lower energy levels by emitting energy. And what Bohr did was, he first did a theoretical calculation based on his model. He presented a model, a mathematical model, and he did theoretical calculations that what should be the frequency or wavelength of the radiations that are emitted. He first did a mathematical calculation. He did not have any experimental proof. Then he did an experiment, and his theoretical values of frequency and wavelength which were emitted by the hydrogen atom, they matched the experimental values quite beautifully. And this validated Bohr's model, which we are going to study as a topic, a separate topic after studying the basics of Bohr's model. We will study this as part of a topic called as atomic spectrum. Right? So I will just keep a note over here so that it's a reminder that these postulates which Bohr had presented, they were validated by the experiment called as atomic spectrum. Check your postulate. So I would say you have Rutherford's model, quantum theory of light, plus certain postulates. What were these postulates? I'm just going to talk about them in a while. And they were all validated by atomic spectrum. Okay. Even the word atomic spectrum might be alien to you right now because you don't know what spectrum is. So we are going to talk about first what spectrum means and then what atomic spectrum would be. However, this will be an interesting journey. Okay. ध्यान से आप observe करना. So let me first talk about the postulates of Bohr's model. These were certain theoretical points which Bohr had presented, that this is how atoms should be. एक एक करके चलेंगे. हाँ, I'm sure you guys have some doubts and some points to say, but थोड़ा सा wait करना, because I would want you guys to go through these postulate ones, and most of your doubts might get cleared while we are discussing these postulates. So give me 5 to 10 minutes, then we will do a discussion. Okay, so first postulate. Electron revolves around the nucleus in certain, ठीक है, not random, in certain circular orbits. Okay, in fact, I will highlight here, not any random orbit, in certain circular orbits called as shells or energy levels. Why they are being called as energy levels, we'll talk in a while. These orbits इनके बारे में एक स्पेशल एस्पेक्ट है. These orbits must fulfill an important condition. These orbits must fulfill, I should rather using the word fulfill, I should rather say that these orbits are governed by the concept of, ठीक है, थोड़ा सा heavy word है, quantization of two things, energy and momentum. And particularly यहाँ पर, because it is going in circular motion, angular momentum. Now, what do I mean by concept of quantization of energy? This is something that we had studied as part of the quantum theory of light. However, we are still going to explore this more from the perspective of Bohr's model. This is something new, the second point. What about this concept of quantization of angular momentum? So यहाँ पर notice करना, without getting into much of the derivation part of it, I will first talk about that what is meant by this concept of quantization of angular momentum. So you guys all understand momentum? Have you come across this term momentum? Right. So you have come across this term momentum as m into v. And that was something which was when you had studied linear motion, right? You have an object of mass m moving with the speed v, and we talk about that, okay, this moving object moving with the speed v has a property which we call as momentum, and that momentum is a vector quantity with a magnitude defined by m into v. ठीक है, उसी तरीके से अभी you might have not studied circular motion, ठीक है, और some of you might have also studied circular motion, but circular motion में भी, right, when an object is in circular motion, then we say that there is an angular momentum associated with the particle, right? Because around a center, the object, say some object of mass m, is moving, you know, at some radius r with a speed, say v, right? Then we define a quantity called as angular momentum associated with it, and it is given by m into v into r. ठीक है, फिजिक्स में आपको सिखाते हैं that this is the formula for it. ठीक है, so I'm taking a bit of a you know, direct knowledge from physics, especially from circular motion, that this is how angular momentum is defined. M mass का object moving with a speed v, tangential speed v, in an orbit of radius r. This is how angular momentum is written. Okay, now what we are saying, ठीक है, once you have understood what is meant by angular momentum, तो यहाँ पर आप notice करना what this concept of quantization of angular momentum is. Just give me a moment. Quantized angular momentum of an electron around nucleus. So L, which I just spoke about, this is the symbol that is used for angular momentum. जिसका formula I just spoke about as m into v into r, right? M stands for what? Mass of electron. V stands for tangential speed of electron. R stood for what? Radius of orbit, right, in which the electron is revolving around the nucleus. So that angular momentum, this is quantized, right? What do I mean by quantized? That it cannot be any random value. It cannot be 1 या 1.1, 1.2, 2.2, ऐसे randomly कुछ नहीं हो सकता, ठीक है, in appropriate units of course. What board suggested was this angular momentum is going to be an integral multiple of h upon 2 pi. What do I mean by this? यहाँ पर notice करना, n will be the orbit number, or you know, just the multiple of h upon 2 pi. That is, it can be 1, 2, 3, 4, like only an integral multiple of h upon 2 pi. You remember what h was? H was Planck's constant, right? And pi is of course the age old 3.14 and so on and so forth. So what Bohr suggested, like, or Bohr postulated, ठीक है, ध्यान से notice करना, what Bohr postulated was that nucleus is at the center and electron can revolve around it. ठीक है, दोबारा ध्यान से सुनना, nucleus is at the center, electron can revolve around it in circular orbits. However, it can only do so in certain orbits only. And one of the conditions for those orbits is that angular momentum of the electron, right, L जो हमने बात करा, should be an integral multiple of h upon 2 pi. So this can be your first orbit in which the electron can revolve. In this, the angular momentum of the electron, ठीक है, I have drawn this like a partial curve only. मैंने पूरा नहीं draw करा, आपको चाहिए तो आप पूरा भी draw कर सकते हो, but it will just take up more and more space for me. So electron can revolve in a particular orbit, ठीक है, not just any random orbit. And the condition for that is that angular momentum has to be an integral multiple of h upon 2 pi. So this can be the second orbit. This can be the third orbit. Right? In the third orbit, the angular momentum will be 3 times h upon 2 pi. In the fourth orbit, the angular momentum can be 4 times h upon 2 pi, and so on so forth. ठीक है, यहाँ पर ये इलेक्ट्रॉन है, m मास का है, v इसकी स्पीड है, एंड इसका डिस्टेंस, ठीक है, इसका मास ऑफ इलेक्ट्रॉन तो कांस्टेंट है, ठीक है, मास ऑफ इलेक्ट्रॉन तो कांस्टेंट है, इसका रेडियस एंड इसका स्पीड ऐसा होगा इन दैट ऑर्बिट that the angular momentum will be an integral multiple of h upon 2 pi. Only those allowed orbits are there in which electron can be present, not just any random orbit. ठीक है. So this was the first postulate. ठीक है. What is the tangential speed? So tangential speed is something which we so what I mean by tangential speed is simple speed only. ठीक है, Jyotsna, it's simple speed only, but the direction of that speed is tangent. Like क्योंकि हम लोग velocity as a vector quantity define करते हैं ना, तो magnitude उसका v है, but उसका जो direction है that is always along the tangent. Like so if the electron is present over here, इसका magnitude v रहेगा, but उसका direction will be along the tangent. ठीक है, so that is why we use this term called as tangential speed. ठीक है. हाँ, see I am not using words which are going to be more confusing because circular motion आप लोगों ने पढ़ा नहीं है. ठीक है, so angular velocity, like अपने आप में अभी to use angular momentum I am a bit skeptical because you guys have not studied circular motion as a concept in physics. अभी आपने simple linear motion ही पढ़ा होगा, like you have m mass object, it is going in a linear motion, right? अब आप धीरे धीरे complexity बढ़ाते हो physics में, you will talk about the object going in circular motion and then you will study that as a separate chapter. So यहाँ पर I am actually taking a kind of a leap in which I am using certain terms like angular momentum, tangential speed, which might sound a bit of a uneasy term to you, but these are crucial for me to develop this Bohr's model of atom at its postulates. So bear with me for a while regarding these terms. Okay? And if you are stuck anywhere, do let me know. I'll try and simplify them for you as much as I can. Okay. So did you guys get the first postulate? ठीक है, इसके पीछे thought process क्या था? ठीक है, it didn't come out of the blue for Bohr. He had done certain mathematical analysis. He had done certain derivations, which helped him develop this concept of quantization of angular momentum also. ठीक है, we are not going into the background of it because it requires a bit of more knowledge of physics. But I'm presenting that result in front of you in a very simple manner, which is an improvement over Rutherford's model, that electron is going to revolve around the nucleus, but not in any random orbit. It revolves in orbits which have particular values of angular momentum of electron. And those values are integral multiple of h upon 2 pi. ठीक है, this h upon 2 pi यहाँ पे notice करना, this h upon 2 pi is sometimes represented by the symbol h bar या h cross. ठीक है, they kind of because this h upon 2 pi features often, so what they end up doing is that h upon 2 pi ko they would represent by this symbol called as h cross. ठीक है, you might come across this symbol also sometimes. ठीक है, now that is right. Kanupriya is asking me, sir, how did we arrive at this result? How did we come up with this result? L is equal to mvr upon nh, L is equal to mvr is equal to nh upon 2 pi. ठीक है, so that is where Kanupriya I mentioned that इसमें थोड़ा physics और लगता है, and it is something which you can understand. ऐसा नहीं है कि you can't understand this. In fact, I would love to talk about it, but थोड़ा सा physics पढ़ लो. Like थोड़ा सा physics मतलब you study the concept of circular motion and you study the concept of electrostats in physics. Then you will be in a much better position to understand how this quantization of angular momentum as a concept came into being. ठीक है, हाँ, इसका proof वाला part will be a bit of a challenge right now. That's where I'm asking you to first understand this postulate. Okay, now having understood this first postulate, let's talk about the second postulate, which is regarding this energy only, जो हम लोगों ने भी थोड़ी देर पहले बात करा था, quantized energy levels. So उसी को मैं further यहाँ पर elaborate करूँगा. So यहाँ पर notice करना, as long as electron revolves in a particular orbit, it neither loses energy nor gains, or in fact I should say it neither loses nor gains energy. Thus energy associated, ठीक है, ध्यान से नोटिस करना, energy associated with an electron remains conserved as long as it is in that particular orbit only, as long as it remains in the particular orbit. Thus energy associated with an electron is conserved as long as it is present in a particular orbit. Now अब यहाँ पे नोटिस करना, the first and the second postulate are actually interrelated to each other. ठीक है, in fact आपने बहुत अच्छी बात कही सूर्या. So Surya has talked that can the second postulate be derived from the first one. So Surya, if you were to think of it some months down the line, जब आप थोड़ा physics और पढ़ लोगे, तो actually first and second postulate both are linked with each other. ऐसा नहीं है कि एक isolation में था दूसरा isolation में था, दोनों are interconnected with each other. That is why in the summary statement I talked about this concept of quantization of energy and angular momentum together. So यहाँ पर in the second postulate what we are saying is that as long as the electron revolves in the particular orbit, right, it neither loses energy nor gains energy, right? Energy is constant in that orbit only. So जैसे मैंने यहाँ पे बताया आपको, you have the nucleus, and nucleus के around you have these energy levels, right? इनको हम लोगों ने नाम दिया n equal to 1, n equal to 2, n equal to 3. These are the number that we give to the orbits, right? या फिर इसको हम लोग ऐसे synonymously बोलते हैं, ऐसे k shell, L shell, M shell. This is a nomenclature that was also given. For the first orbit, we can use the term K shell. For the second orbit, we can use the term L shell. For the third orbit, we can use the term M shell, and so on and so forth. Right? So with each orbit, there is a particular energy associated with electron. If the electron is present in n equal to 1, it will have a particular energy, say E1. If the electron is present in n equal to 2, then it will have a particular energy level, say E2. If the electron is present in n equal to 3, then it will have a particular energy level, which is E3. Right? So these are energy levels or energy associated with electron when it is present in the particular orbit. In fact, we are going to prove in some time. I will just put it as a note. Okay, we will prove it later. Okay, when I mean later, like maybe in today's class only or in the next class, that lower orbit has lower energy, higher orbit has higher energy. Okay, we are going to talk about it. Lower orbit has lower energy, so E1 will be less than E2, will be less than E3, and so on and so forth. Higher orbit has higher energy. Yeah. हाँ, ठीक है. Now, अब यहाँ पर notice करना, this is not where the postulate ends. ठीक है, there is additional piece of information along with this postulate. तो यहाँ पर ध्यान से सुनना. When an electron jumps, ठीक है, we use the word, a more technical word called as excitation or de-excitation. Sorry. So when an electron jumps from one orbit to another, from one orbit or energy level to another, it absorbs or emits energy in form of photon. And the interesting thing is, यहाँ पर notice करना, ये जो photon emit या absorb होगा, इसका energy कैसा रहेगा? So it absorbs or emits energy in form of a photon corresponding to the energy gap between concerned orbits, जिनके बीच में jump हुआ है. What do I mean by this? Let me elaborate it a bit more. So what you can think of here is, say, excitation. excitation will be a jump from a lower energy level to a higher energy level. So you have a nucleus के around, say you have a lower energy level n equal to 1, and this is a higher energy level n equal to 2. Like this is E1, this is E2. Like E2 is greater than E1, right? Now electron is present, say in n equal to 1, and it will absorb photon, okay, h nu, and make a jump into the higher energy level, say n equal to 2. Okay, this was a lower energy, this was of higher energy. So how much will be the energy absorbed? तो यहाँ पर notice करना that energy of this photon is delta E. ठीक है, it will be, what is delta? Delta is always final minus initial. Energy final minus energy initial. What was the final energy? It was E2. What was the initial energy? E1. Right, so this h nu will be equal to, right, we remember energy of photon, we can write it as h nu. It will be E2 minus E1. And यहाँ पर when you will do the calculation, ठीक है, चलो इनफैक्ट कैलकुलेशन की बात बाद में करेंगे, बट दिस इज एक्साइटेशन. अब साथ में ही ऑब्जर्व करना डी एक्साइटेशन एज वेल, right? So the electron can go from lower energy to higher energy orbit, or it can come from higher energy to lower energy also. We call that as de-excitation. So let's say you have nucleus, and nucleus के around you have these energy levels, say n equal to 1, n equal to 2, E1, E2. E2 is greater than E1, and this time the electron was present in n equal to 2, and it de-excited into n equal to 1, and it did so by releasing energy through a photon. And again, as we just did over here, यहाँ पे sign convention समझना ध्यान से, energy of this photon is delta E, which will be equal to, again, delta by convention is written as E final minus E initial, right? Change is always final minus initial. Okay, please note this convention. What was the final here? E1. What was the initial over here? E2. Right? ये समझ में आया? अब notice करना, यहाँ पर you will have a negative sign. Why? Because E2 was greater. Okay, so don't get confused by the negative sign. What will negative sign just imply? Negative sign just implies that it is energy released. Okay, there is nothing like negative frequency or anything. We follow the convention that change is always final minus initial, and here upon doing final minus initial, we will get negative sign on the right hand side, and that will just imply that it is energy released. Okay, all you need to report is the, or all you need to focus on is the magnitude, and then calculate the frequency or wavelength when I'll ask you to do that. Here on the left hand side, it would have been a positive sign only because E2 is greater than E1. The positive sign implies that it is energy absorbed. Right here, E2 minus, even because E2 is greater than E1, this is going to come as positive only, and that positive sign implies that it was the photon, right, that got absorbed. It was the energy that was absorbed. Here, it would mean that it was the energy which was released. So this was an important postulate coming from Bohr's model. And as I said, this was on paper. Okay, these postulates right now, which Bohr had presented, he did all this mathematical derivation and came across these findings, which were on paper, which were theoretical in nature, which he then validated. Like I just spoke about this term, that he validated using this experiment called as atomic spectrum, right? So बोर ने क्या करा, बोर ने ये सब values calculate करके दी, that okay, hydrogen atom में ये सब energy values होंगी, like he calculated the values of these frequencies that will be emitted or absorbed, and they matched with the experimental observation with hydrogen atom, and that is where he got his validation. Okay, so we are going to build to that in a step by step manner. So I hope you understand these postulates. Now, before I proceed further, okay, let me do a quick session of doubts that you might have regarding these postulates. So let me know. I think I already have a lot of students. हाँ, बोलो गौरव. Any doubts in these postulates?
No, sir, I got them cleared.
Okay. हाँ. Prakash?
Yes, sir.
Hmm.
Sir, I have a doubt, sir. If a particular frequency is absorbed by the electron, sir, it will emit it to the nucleus to remain in the same position. Sir, so the energy would be re-emitted by the nucleus to the electron, and electron will eject it out. So, sir, it will remain in the same position. Sir, so why is it following a complex like this?
Okay, so first of all, you took an assumption that the energy absorbed or energy emitted in form of photon is taken up by the nucleus. वो गलत assumption है. Like, where did you come across that thought? जो
Okay, sir.
ऐसा नहीं होगा. मतलब इनफैक्ट आपको अभी मैं जस्ट एक रफ स्केच बता रहा हूँ. ठीक है, रफ स्केच इसलिए बता रहा हूँ ताकि आपका ये डाउट क्लियर हो जाए. जब ये एटॉमिक स्पेक्ट्रम का एक्सपेरिमेंट हम लोग पढ़ेंगे, ठीक है, तो उसमें यू विल हैव अ ट्यूब, एंड इन दिस ट्यूब यू विल हैव अ सैंपल ऑफ हाइड्रोजन एटम्स और हाइड्रोजन गैस, राइट? एंड देन यू एक्साइट दिस हाइड्रोजन एटम का सैंपल, एंड इसमें से जो रेडिएशंस निकल रहे हैं, ठीक है, अपॉन डी एक्साइटेशन, दैट विल बी एनालाइज्ड. ठीक है, एंड दोज
Okay,
रेडिएशन
sir.
दे कैन बी एमिटेड इन एनी डायरेक्शन, लाइक कहीं पे भी एमिट हो सकते हैं. हम एक डायरेक्शन के अलोंग बस एनालिसिस कर लेंगे उसका. ऐसा नहीं है कि वो न्यूक्लियस के अलोंग होंगे या न्यूक्लियस में जाएंगे, वैसा कुछ नहीं होगा.
Okay, sir. Okay, sir. Yes, sir. Thank you, sir.
ओके, ठीक है. देन नेक्स्ट किसका डाउट था? हाँ, बोलो शर्विन.
Yes, sir. So I have two doubts. So my first doubt is, what are these single electron species? Means I had a small question about them.
Right, single electron means that there is just one electron present around the nucleus. So let's say hydrogen atom,
Yes, sir.
that is a single electron species. When you talk about helium, it has got 2 electrons.
Yes, sir.
However, if we were to apply Bohr's model on it, then we will need to remove 1 electron,
Okay, sir. So it becomes a single electron.
single electron species.
Yes, sir. And my second doubt is that, sir, let us assume that the electron jumps from one orbit to the other by taking some X amount of energy. But, sir, there's also a chance, sir, that the electron will absorb, let's say, X point something energy, sir, and then again jumps to the same orbit. So, sir, this doesn't miss this. So this concept of E2 minus E1, sir, then that it gets means failed, sir, because the
Good.
same amount of means the same amount of energy is not used to go to the same orbit, sir.
Good. So you have an interesting doubt,
Yes, sir.
and that doubt is that you have, say, hydrogen atom, and say 100 hertz was the frequency of photon that was required for excitation.
Yes, sir.
Okay, for the electron to go from, say, E1 to E2. What if instead of 100 hertz I provide 110 hertz? Then what will happen? Right?
Yes, sir. It will again jump to the same orbit, sir.
It will not jump. Okay, and we are going to talk about it in a while. Okay, you had a good question. I'm giving you the answer that it will not jump. It will not interact with this photon.
Okay, sir.
Okay, so I will speak about it in a more detail, but to answer your question, it will not interact with this energy photon.
Okay, sir.
हाँ बोलो मोहम्मद.
सर मुझे दो डाउट है.
हाँ.
सबसे पहला डाउट है कि जो h/2 पाई का जो कांस्टेंट था,
हाँ.
ये कैसे आया? ये मतलब इसको समझा नहीं मुझे ये h/2 पाई कांस्टेंट के बारे में.
So देखो, आपको एक डेरिवेशन में कराऊंगा when we are going to study another concept after this called as de Broglie's dual hypothesis.
Okay,
तो उसमें I am going to use this aspect of circumference.
Yes,
वहां से ये 2 pi का concept आएगा, तो that is something which I will talk about as one derivation. And there
okay,
is
sir. हाँ sir.
there is another derivation
sir.
which is done, which is more grounds up derivation from the point of view of physics, जो आप थोड़ा टाइम बाद ही appreciate कर पाओगे. उसमें भी ये circumference से ही आता है 2 pi.
ओके सर. हाँ सर, और आपने बोला था कि नीचे में ये हमारी जो एनर्जी का जो डिफरेंस है सेल्स के बीच में से, जो दो सेल्स के बीच में जो एनर्जी डिफरेंस है, उससे हम लोग फ्रीक्वेंसी निकाल सकते हैं. वो हम लोग कैसे निकाल सकते हैं?
हाँ, वो मैं आपको वही बताऊंगा जब हम लोग ये टॉपिक पढ़ेंगे, एटॉमिक स्पेक्ट्रम.
ओके सर.
उसमें मैं आपको पहले बताऊंगा कि स्पेक्ट्रम होता क्या है एंड देन हाउ डू वी
ओके सर.
मेजर दिस. बोलो आरवीर.
सर बहुत देर से हाथ रेस किए कि हाथ दुख गया था मेरा. सर आपने जो बोला था कि प्रूफ वो बाद में करेंगे सर कि E2 कैसे E1 से ग्रेटर है, उसमें तो सर खाली फॉर्मूला में n का वैल्यू ही पुट करना है ना, या और भी दूसरा प्रूफ है?
हाँ, वही उसको जस्ट एक डेरिवेशन में बताऊंगा जिसमें नेगेटिव साइन के साथ में वो रहेगा, तो आई हैव टू एक्सप्लेन दैट नेगेटिव साइन as sum of kinetic energy and potential energy is negative. तो मैं बताऊंगा. ठीक है. हाँ बोलो सूर्या. हाँ एक मिनट. नहीं, आई थिंक आई एम नॉट एबल टू अनम्यूट यू सूर्या. Okay, go ahead then, Tripti. You ask your doubt.
Sir, if the energy supplied is greater than E2 minus E1, then will photoelectric effect be observed?
Interesting question, which to give you a short answer to it, if the photon is able to eject electron out of the atom, then yes. But if it isn't capable of ejecting electron and not even exciting, then no. ठीक है.
Sir, I did not understand. Can you repeat?
हाँ. So अभी when we were and इस पर I will elaborate also. So you have nucleus and you have nucleus के around energy levels, right? Say electron is in the first energy level, right? And now you bombard it with photons. Now this photon will interact with electron only in two scenarios, right? One will be either it can ionize it, Either it can take it out of the atom or it can excite it. Anything else, we will not find the electron to be interacting with that photon. This is what the concept of quantization of energy is. That at an atomic scale, what we understand is that this electron, it can be present around the nucleus in only discrete energy levels, and only if a photon provides it a particular energy, it can jump into the next higher energy level. Otherwise, it will not interact with that photon. Or if the photon can eject the electron out of the atom, then yes, then the photon or the electron becomes like a free electron and it can come out of the atom.
So
ठीक है, अभी समझ में आया? हाँ, ये थी।
Yes, sir. Understood.
ठीक है, हाँ, बस अब एक लास्ट डाउट मैं ले रहा हूँ ललित, उसके बाद आई विल
sir, you unmuted me.
Sir,
हाँ, एक मिनट रुक जाओ सूर्य.
sir, my doubt was that whether de-excitation would take place when it is in the first orbit.
नहीं, it will not. That will be the ground energy state. That will be the lowest energy state.
Okay, sir.
ठीक है, हाँ सूर्य अब आप बोल दो फटाफट, then we'll resume.
Yes, sir. So, is ionization equivalent to going from some energy level to E infinity?
Yeah. We are going to talk about it in that way only.
Okay, sir. So, and one more thing about how the first second is follows from the first. So, before quantization, I guess the electrons could have been anywhere around the nucleus. So, so I guess so the energy that it emits while going around the atom during acceleration, by according to Maxwell's model, so that would have been less than the energy between two shells, right? Because if it could lose that energy, if it could lose that much energy, then it would, right?
So, okay, what you are trying to maybe understand that the drawbacks of Rutherford's model was the statement coming from Maxwell's theory of electromagnetism, that electron accelerating around the nucleus would lose energy.
Yes, sir.
So that is where things changed post the quantum theory of light. So Maxwell's theory of light was wave theory of light. You remember that?
Yes, sir.
However, when quantum theory of light emerged, it improvised over Maxwell's theory. Like Maxwell had proposed the wave theory of light and elaborated on it, but what came out to be a more detailed understanding that light has not just wave nature, it has got particle nature also.
Yes.
And that is what we captured in this quantum theory of light. So that Maxwell ka drawback was what we would say a perspective, not a drawback. That if we perceive energy to be continuous, then yes, Maxwell's statement does pose a drawback
Okay,
for
so
Rutherford's model.
it doesn't even apply to the scenarios. Okay.
Haan. So when we come across this perspective of quantized energy levels, that is where Bohr improvised over Rutherford's model of atom. That that around the nucleus, electron can have particular quantized energy levels, and it can lose or gain energy by excitations and de-excitations.
Okay, sir.
And this is what he then experimentally validated also.
The losing energy through acceleration is derived only through wave properties. And particle properties it doesn't apply whatsoever in particle.
Correct.
Okay, sir.
ठीक है?
So the thing I said about um, the energy being released due to acceleration being less than that of the energy between the levels, that isn't really
That was
an
the
explanation, is it?
wave theory perspective, that this should be the case, because that wave theory didn't take into account quantized energy levels. उस time पर quantized energy level का concept ही नहीं था. It was continuous form of energy that was being thought about. That, you know, energy as a quantity can be anything. That was what the thought process was. That it can be continuous from 0 to 1 joule. You can have any energy level that you want,
Right.
right? But
Yes, sir.
it was post the quantum theory of light that we understood that if you zoom in at an atomic scale, we find that there are quantized energy
Fixed
levels.
intervals, right.
So that became a
Discretized the
fundamental,
continuum.
a fundamental change in the entire theory of light.
Okay, so it wouldn't make sense to talk about both wave and discrete orbitals at the same time.
Right.
Okay, thank you, sir.
All right. So now that we have established these postulates, ठीक है, अब यहाँ पर ध्यान से सुनना. Let me talk about certain mathematical results of Bohr's model of atom. Right. Again, as I said, it is valid for a single electron species. What were these mathematical results? So this is something which you can also, kind of think about. That okay, Niels Bohr presented this model of atom, saying that, you know, atom is what Rutherford had proposed, that you will have nucleus, and around the nucleus you will have these energy levels. So your first question would be that, okay, if you are saying so, that okay, this is the first orbit, इसका radius r1 है, इसमें अगर इलेक्ट्रॉन प्रेजेंट है, राइट, तो उसकी स्पीड से v1 होगी. तो can you give me the value of what r1 and v1 would be? Can you tell me how many meters, kilometers, micrometers is r1? Can you tell me how fast is the electron moving, like 1 meter per second, 20 meter per second, 1000 meter per second? What is the conclusion? And this is what we are going to talk about in this particular section, which is mathematical results of Bohr's model of atom. So यहाँ पर अब आप नोटिस करना, एज अ रिजल्ट मैं आपको पहले लिखा देता हूँ, ठीक है. लेट मी राइट डाउन दीज रिजल्ट्स फॉर यू, देन वी विल आल्सो टॉक अबाउट देयर प्रूफ, ठीक है. सो लेट मी इलैबोरेट ऑन द रिजल्ट्स फर्स्ट. So let me talk about the first result, which is r, that is the radius of nth orbit. ठीक है, n can be 1 2 3 anything. So इसका result was 0.529 into n square by z. Z will be the atomic number of the single electron species. I'll talk about it in a while. This was the first result, that radius of the orbit can be given by this formula, that r is equal to 0.529 into n square by z. N will be the number of the orbit, z will be the atomic number of the single electron species. For example, if I ask you this question, what will be the radius of second orbit of helium plus, ठीक है, तो आपका आंसर क्या रहेगा? you will simply go ahead and write 0.529 into n का value कितना हो गया 2 because this is the second orbit. So 2 का square and helium plus का z कितना रहेगा 2, right? Z be the atomic number. Let me यहाँ पर this n corresponds to the orbit number and this z corresponds to the atomic number and angstrom will be the unit. ठीक है? So this will be your answer. Correct. Then second result, ठीक है, यहाँ पे focus करना. Second result was related to the speed, right? Or I should say tangential speed. Commonly speed ही बोलेंगे. Tangential speed of electron in nth orbit. ठीक है, कोई भी फर्स्ट ऑर्बिट में होगा या सेकंड ऑर्बिट में होगा तो उसकी स्पीड कितनी होगी. सो दिस वाज गिवन बाय द और दिस वाज डिराइव्ड एज 2.16 into 10 raised to the power of 6 into z by n meter per second. Z being the atomic number, right, and n being the orbit number. Right, so it's a pretty high speed if you take it into perspective. You will have to remember these results. That's why I'm writing these results up front. अब इसके बाद नोटिस करना थर्ड रिजल्ट. ठीक है, मैं थर्ड रिजल्ट आप लोगों को लिखवा रहा हूं पहले, ऑल्दो इसका डेरिवेशन भी हम लोग क्विकली अभी देख लेंगे. सो यहाँ पे नोटिस करना द थर्ड रिजल्ट विल बी अनदर क्रूशियल रिजल्ट व्हिच आई टॉक्ड in terms of the energy levels, right? We spoke that first orbit has a energy level E1, second orbit has E2 and so on so forth. ठीक है, so यहाँ पर I will put the result first. Say E, that is the energy of electron in nth orbit. ठीक है, कितना जूल, किलो जूल, कैलोरीज की यूनिट में नहीं देख रहे हम लोग, इसको हम देखेंगे ईवी की यूनिट में, इलेक्ट्रॉन वोल्ट्स की यूनिट में. दैट विल बी द प्रेफर्ड यूनिट दैट वी विल हैव. दिस विल बी minus 13.6 into z square by n square ev इलेक्ट्रॉन वोल्ट. ठीक है, minus 13.6 into z square by n square. Why is there a minus sign? It is something which important to understand. I'm sure you guys are curious about the matlab negative energy. Like, what do we mean by negative energy? Is this some dark energy, negative energy, or is it something which is right? A difficult concept to comprehend. The answer is no. I will talk about it once we are in the derivation. Okay, what do I mean by this negative sign with the energy? Okay, but first, as I said, I would want you to be familiar with the results, क्योंकि results काफी ज़्यादा use होंगे. ठीक है, so I don't want to undermine their importance. Now that you are familiar with the results, that okay, these are coming from Bohr's model of atom, let's go into their derivation. ठीक है, हाँ, एक एक करके चलेंगे. Okay, there is some doubt which was raised by some of the students. If you guys can wait for the derivation. Yeah, hi Aryan.
Yes, sir. I had one doubt. This shortcut is in electron volt. So, is there a shortcut for the SI unit as well?
It would be. However, you are required to remember this from the basic perspective. You can always do the interconversion. So you don't need to remember multiple shortcuts. You remember this, and now you remember the interconversion between EV and Joule, so you can work on that.
Okay, thank you, sir.
ठीक है, all right. हाँ, now we come to this derivation. ठीक है भाई गिरीश, आई एम कमिंग टू दैट डेरिवेशन बिट ओनली. सो यहाँ पर नोटिस करना इनका प्रूफ, लाइक हाउ डिड Niels Bohr come up with these results. In fact, let me leave some space for the energy bit because यहाँ पर मैं थोड़े से और results आपको बाद में लिखाने वाला हूँ. So let me write the proof below this. All right. So what we have in front of us is, ठीक है ना, assume that this is a circle because I'm really not that good at drawing the circle over here. So you have, say, m is the mass of electron. It is moving with the speed v in the orbit of radius r. Okay, this is your electron and this is your nucleus with the charge or the atomic number that is z. Now, one important result that we had was quantization of angular momentum. This was one important result that we will use as part of our proof, that mvr, right, the angular momentum mvr is equal to nh upon 2 pi, like it is an integral multiple of h upon 2 pi. So this will be the first equation that we'll be using. Second equation that will come to our help is force balance on electron. What is that force balancing on electron? तो यहाँ पर आप notice करना, this electron is moving in a circular orbit, right, at a distance r from the center. Okay, now this electron is experiencing two types of forces. One is the attraction by the nucleus, right? This is your electrostatic force of attraction between the nucleus and the electron. And because this electron is going in circular motion with the speed v, there is this outward force. What is this outward force called? ये आप लोगों ने शायद सुना होगा and experience भी किया होगा, like when you would have yourself played on a merry-go-round or something like that. You would have experienced this force. This is the centrifugal force. And this is in the radially outward direction. And as long as these forces balance out each other, the electron is going to be stable in its orbit. Now when I'm going to explain, or I'm going to write down the mathematical formulas for these forces, it will be again a leap of faith because you have not studied circular motion, you have not studied electrostatics in physics, you have not studied both these concepts. So यहाँ पर it will be again a leap of faith, तो ध्यान से सुनना. Centrifugal force is written as mv square by r. this is how we write centrifugal force. I would put a note over here, refer circular motion. This is something which will be taught to you in physics again, that how do we write centrifugal force. Right? आपको एक जनरल फोर्स की अंडरस्टैंडिंग है, F is equal to mass into acceleration, बट ये जो एक्सेलरेशन रहेगा सर्कुलर मोशन में, ठीक है, इनफैक्ट मास भी हम लोग मोमेंट ऑफ इनर्शिया से रिप्लेस करते हैं, तो वो चीज आपको सर्कुलर मोशन चैप्टर में सिखाई जाएगी. अभी के लिए as I said, just take it for granted that centrifugal force is written as mv square by r. ठीक है. Then electrostatic force of attraction. ठीक है, ये हम लोग कैसे लिखते हैं? So this is something similar to gravitational force जो आप लोगों ने अपने जूनियर क्लास में देखा था, that q1 q2, if there are two charges at some distance r from each other, right, then electrostatic force is written as k q1 q2 by r square. Okay, this was two charges at a distance r from each other. तो उसमें जैसे ग्रेविटेशनल फोर्स आपने पढ़ा होगा g m1 m2 अपॉन r square, तो वैसे इसका डेरिवेशन रहता है. However, I am using it here directly. So you will have the electrostatic force, which is k. K is a electrostatic force constant. Charge of the nucleus is Z times E. Z will be the number of proton and charge of each proton. Then minus E will be the charge of electron. So this is Q1, this is Q2. Q1 क्या हो गया? Charge of nucleus. ये Q2 क्या हो गया? Charge of electron. ठीक है? And R is the distance between them, right? So R square. And इसका, like the minus sign denotes attractive force. Okay, so I'm talking about the magnitude over here. Okay, this minus sign, it denotes that the force is attractive in nature. So I'm just going to take the magnitude of it. So k q1 q2 by r square. This will be your second equation. Okay, let me elaborate on the terms here. एक एक करके. K is the electrostatic force constant. K is equal to 1 upon 4 pi epsilon naught, which is equal to 9 into 10 raised to the power of 9 Newton Coulomb square, or in fact Newton meter square अपॉन कूलम स्क्वायर. ये इसकी SI यूनिट वैल्यू हो गई. ये मैं आपको बता रहा हूँ, आई एम नॉट एक्सपेक्टिंग कि आपको ये पहले से पता होगा. दिस इज आई एम टेलिंग यू दैट ओके, दिस इज द इलेक्ट्रोस्टैटिक फोर्स कांस्टेंट. जैसे आपने ग्रेविटेशनल कांस्टेंट G के बारे में पढ़ा होगा, उसी तरीके से ये एक इलेक्ट्रोस्टैटिक फोर्स का कांस्टेंट रहता है, जिसका वैल्यू आपको ध्यान में रहना चाहिए. Then you have Z. This was the atomic number of single electron species. Right, so if you have hydrogen atom, then Z will be 1. If you have helium plus ion, then Z will be 2. If you have lithium 2 plus ion, then Z will be 3, and so on and so forth. E will be equal to the elementary charge which we again know the value of is 1.6 into 10 raised to the power of minus 19 coulomb, right? M is the mass of electron, which is 9.1 into 10 raised to the power of minus 31 kilograms. V is the speed of electron in nth orbit. R is the radius of nth orbit, right? N was what we were talking about as the orbit number. It is the first orbit, second orbit, and so on and so forth that we are here in nh upon 2 pi, and h, as you know, is Planck's constant. Now, as an overview of these two equations, can you notice that in these two equations, the unknown that we have is V and R, right? So for example, if I take, say, hydrogen atom and uska first orbit, right? Hydrogen atom and uska first orbit, so that means Z is equal to 1 and N is equal to 1, right? That I have taken. And now mass of electron is something I know, right? Planck's constant is something that I know. K, E is something that I know. K and the value of E. So the only unknown in these two equations are V and R. So can you guys do me a favor and two equation, two variable, solve for the value of V and R? Just do some math, do some substitution, and can you get me the result of V and R from these two equations? हाँ, फटाफट बताओ. Right, Gaurav, correct. R का भी निकालो. हाँ, राइट आ रहे वीर. थोड़ा सा तुमने एक गड़बड़ किया है, तुम पाई भूल गए इनमें. तो वो थोड़ा देखो. हाँ, in terms of these variables only, in terms of these k, z, pi, इन सब के टर्म्स में निकालो. हाँ, नहीं श्रेय, मैं आपको बताऊंगा. We will talk about it when we will be doing atomic spectrum experiment. Then I'll be talking about this. How did we excite and de-excite the electrons? आप ऐसा करो ना, यहाँ से R को सब्स्टिट्यूट कर दो. लाइक R आपने जो निकाला है यहाँ पर NH अपॉन 2 पाई mv, इसको यहाँ पर सब्स्टिट्यूट कर दो. तो देखो क्या आ रहा है. ठीक है, अपॉन सॉल्विंग the first and the second equation, right? what I will get, I'll get V is equal to 2 pi k z e square upon n into h. ठीक है, in which I can segregate these terms. ये 2 pi k e square upon h इसको मैं अलग कर देता हूँ, into z by n को मैं अलग कर देता हूँ. ये आया आप लोगों का रिजल्ट. Were you able to substitute r from first into the second equation? हाँ, I'll okay do this for you. Okay, k z square by r square was equal to mv square by r. This was one equation, and the other was mvr is equal to nh upon 2 pi. Correct? अच्छा, अब यहाँ से आप r देखो, r क्या आ रहा है? nh upon 2 pi mv, राइट? और एक ये r यहाँ से कैंसिल आउट होकर मैंने यहाँ पे सब्स्टिट्यूट कर दिया, तो ये कैसा हो जाएगा? k z e स्क्वायर अपॉन ये r था, ठीक है? तो ये r की जगह मैं क्या लिख रहा हूँ? nh अपॉन, तो ये अपॉन न्यूमरेटर में चला जाएगा, 2 पाई mv इज इक्वल टू mv स्क्वायर, राइट? तो ये एक m कट गया, एक v से ये v स्क्वायर कट गया, तो v आपका आ गया द रिजल्ट दैट आई वाज टॉकिंग अबाउट. ठीक है, ऑलराइट. नाउ अब यहाँ पे नोटिस करना, आपको 2 पाई के ई और एच इन सबका वैल्यूज आता है, राइट? ऑल दीज values are something which are known to you, so you substitute them and what you get is 2.16 into 10 raised to the power of 6 into z by n meter per second. That is the result that we had spoken about some time back. Similarly, you substitute r, okay? You kind of इस v को you substitute in, say, back in first equation, then you will get r as h square upon 4 pi square m k e square into n square by z. ठीक है, now I'm not doing the steps all over again. ठीक है, आप इसी v को सब्स्टिट्यूट कर दोगे in the first equation or something, you will get this, and then if you again like put down the values of these are all some known quantities, so you put down the values of these, ठीक है, and you will get the answer as 0.529 into n square by z in the units of angstrom. ठीक है, all right, and this is pretty simple, straightforward. It's not really difficult to get these two results of v and r. ठीक है, एनर्जी के रिजल्ट पर भी हम आएंगे, but just wanted to get you a quick derivation of it. You might not even remember the derivation right now, that's okay. At least you should know how to use these results. Now, how do we use these results numerically? अब आप बहुत ध्यान से देखना, बहुत ध्यान से फोकस करना, because I'm going to take you through the kind of questions that can come from this part. So what can be the simplest kind of question that can come? So something like this: determine the radius of first orbit of helium plus ion. This is the simplest kind of question that you can come across, right? You just put the value of Z and N. So you remember the formula that okay, सर ने derive करके बताया था हमें R is equal to 0.529 into N square by Z angstrom, right? And by looking at the question, we can understand that N is given as 1 and helium plus ion hai, so Z is 2, right? So if I substitute that over here, I will get my answer as 0.529 by 2. 0.529 into 1 ka square upon 2 angstrom. And that will be my answer. This was the simplest kind of question. ठीक है. However, थोड़ा सा लेवल बढ़ाएंगे. आप इतने बेसिक क्वेश्चंस के साथ में डील नहीं करोगे. थोड़ा सा अब आपका लेवल किस तरीके से बढ़ाएंगे यहाँ पे नोटिस करना. In another example, if the radius of second orbit of helium plus ion is x, then the radius of say second orbit of hydrogen will be what in terms of x? You will have to answer. नहीं आर्यन. हाँ करेक्ट तौसीफ, करेक्ट मिहिर. हाँ जैनब आपका सही है. नहीं क्षितिज आपका सही नहीं है. राइट प्रकाश, राइट अनवी. द आंसर इज 2x. कैसे आया ध्यान से नोटिस करना, राइट. R is proportional to n square by z. ठीक है, you'll have to use the proportionality. You don't need to get into putting the values because आपको x के terms में ही पूछा है, right? Since R is proportional to n square by z, so यहाँ पर आप नोटिस करना radius of second orbit of helium plus. ठीक है, मतलब मैं इनफैक्ट इस तरीके से अगर आपको बोलूंगा तो यहाँ पर आप नोटिस करना R of case 1 upon R of case 2 is equal to n square by z of case 1 upon n square by z of case 2. Now, what is this case 1, case 2? This is to kind of simplify what is there in the question, right? This will be your case 1. Right? And this will be your case 2. So इसको मैं कैसे लिख दूंगा? रेडियस ऑफ, ठीक है, लेट मी पुट इट, रेडियस ऑफ सेकेंड ऑर्बिट ऑफ हीलियम प्लस. तो यहां पर अब मैं n का वैल्यू क्या डालूंगा? 2. और हीलियम का z क्या रहेगा? हीलियम प्लस आयन का 2, करेक्ट. अपॉन रेडियस ऑफ क्या पूछा आपसे? सेकेंड ऑर्बिट ऑफ हाइड्रोजन. तो सेकेंड ऑर्बिट ऑफ हाइड्रोजन. सो n का वैल्यू वापस से 2 रहेगा, करेक्ट. एंड z का वैल्यू 1 रहेगा, राइट. सो दिस इज x and this is the unknown. So you get the unknown to be equal to 2 times x. समझ में आया कैसे करा? For those who could not get it in the first place, इसमें केयरलेस मिस्टेक्स अवॉइड करनी है. बाकी है तो ये बहुत ही सिंपल, लाइक अल्ट्रा सिंपल आई वुड से. बट ठीक है, धीरे धीरे आपको इसकी आदत पड़ेगी. ओके, यहाँ पर एक क्विक एग्जांपल और देखते हैं, उससे प्रैक्टिस करते हैं. So let me put it in this way. If the radius of third orbit of hydrogen is r, then diameter of first orbit of helium plus is in terms of r. All right, so ऊपर वाले क्वेश्चन का आंसर, करेक्ट आंसर इज r by 9. r divide by 9. That will be the correct answer. ठीक है, कैसे? अभी आपने नोटिस किया ना, हमने वही यूज किया, r is proportional to n square by z, right? So radius of third orbit of hydrogen, ठीक है, third orbit of hydrogen upon radius of first orbit of helium plus, right? तो यहाँ पर 3 का स्क्वायर अपॉन 1 डिवाइडेड बाय 1 का स्क्वायर अपॉन 2, right? And this was given as r, and this is the radius. Although radius नहीं पूछा है मुझसे, तो यहाँ से मेरा आंसर क्या आ जाएगा? That this will be r by 18. But this is the radius, ठीक है? I have been asked diameter. तो आपने जल्दबाजी में आंसर आने की खुशी में r by 18 को आंसर मार्क कर दिया तो गड़बड़ हो जाएगी. हाँ भाई, मैं डेलिबरेटली ऐसे ऑप्शंस डालता हूँ जिसमें आई नो स्टूडेंट्स वुड कमिट दिस केयरलेस मिस्टेक एंड गेट नेगेटिव मार्क्स. सो लाइक कंसिडर दिस एज माय sadist nature, that I really enjoy setting traps for students, and then they get those negative marks, and then like I feel this sense of satisfaction that okay, I don't know, but this is some sadist character that I have, which you will get exposed to many times in future, especially जब tests होंगे. So this is not the correct answer. The correct answer is that diameter will be 2 times r by 18, and r by 9 will be your correct answer. हाँ, चलो लास्ट वाला बताओ, ये वाला क्वेश्चन, इस वाले का क्या रहेगा? This is another you can say level of question. अब इसमें मैंने थोड़ा सा और लेवल बढ़ा दिया है, सो इट इज समथिंग न्यू। लाइक ये सर ने टाइम पीरियड ऑफ रेवोल्यूशन के बारे में क्या बात कर ली, ये तो पढ़ाया ही नहीं, सिखाया ही नहीं। लाइक व्हाट डज इट मीन? हाँ, अभी तक तो किसी ने भी करेक्ट आंसर नहीं दिया है। हाँ, मैं आपको फॉर्मूलाज दिखा देता हूँ। फॉर्मूलाज ये थे, v was proportional to, in fact let me write it down over here itself, that v was proportional to n square by, oh sorry, z by n, and r was proportional to n square by z। ये proportionalities के साथ में आप वर्क करोगे तो you will have a faster problem solving approach rather than substituting the values। ये proportionalities के साथ में वर्क करोगे तो जल्दी आंसर आ जाएगा। मैं थोड़ा सा जूम आउट कर लेता हूँ so that you can see this is second orbit of H and second orbit of Li2 plus। तृप्ति, आपका पहले आंसर करेक्ट था, फिर आपने चेंज कर दिया। पहले वाला करेक्ट था। हाँ, right, some students are able to get the correct answer, right Satvik, right Shreyas। So इसमें आप नोटिस करो, let me help you a bit more, what is time period of revolution? It will be distance upon speed, right? Distance कितना रहेगा एक revolution में? The circumference 2 pi r and speed is v, right? So what you can see from here is that this time period is proportional to r by v, right? 2 pi तो constant है तो ठीक है, उसको हटा दो। Time period is proportional to r by v। Now can you use the results that r is proportional to n square by z and v was proportional to z by n? If I substitute them over here, right, time period is proportional to r by v, r को मैंने यहाँ substitute कर लिया, that r was proportional to n square by z, so I substitute that over here, and v was proportional to z by n, that I substituted over here. So I get an important result that time period is proportional to n cube by z square, right? I hope ये इतना math अपने को आता है, like I don't have to explain what things goes in numerator, what thing goes in denominator. I hope you are able to connect this, right? अब मैंने इतना हेल्प कर दिया है तो अब आप आंसर निकालो, राइट? अब हमारा कैसा रहेगा टाइम पीरियड इन द फर्स्ट केस? व्हाट वाज द फर्स्ट केस? सेकंड ऑर्बिट ऑफ हाइड्रोजन, सेकेंड ऑर्बिट ऑफ हाइड्रोजन अपॉन, हमसे पूछा जा रहा है टाइम पीरियड इन द सेकेंड ऑर्बिट ऑफ लिथियम 2+। तो मैं यहाँ पर क्या लिखूंगा, 2 का क्यूब अपॉन 1 का स्क्वायर, राइट, n is 2 and z is 1 for hydrogen, अपॉन 2 का क्यूब बाय लिथियम 2+ का z कितना रहेगा, 3 का स्क्वायर, राइट। तो अपॉन सॉल्विंग दिस, ये 2 क्यूब कैंसिल आउट हो जाएगा, 3 स्क्वायर ऊपर आ जाएगा, तो ये 9 रहेगा, राइट। दिस वाज t and this was the unknown, so your answer comes out to be t by 9. That is what your correct answer is. ठीक है, ये समझ में आया अभी? Let me zoom out. Right, so apart from getting the simple results of V and R, this time I enhanced the level of question and asked you something which was not taught to you in this lecture. ठीक है, मैंने आपको टाइम पीरियड के बारे में नहीं बताया था, बट टाइम पीरियड ऑफ रेवोल्यूशन, डिस्टेंस अपॉन स्पीड, ये तो आपको पता होना चाहिए, तो उससे आपको एक्स्ट्रापोलेट मैं करवा रहा था, ठीक है। एंड फर्स्ट टाइम में नहीं हुआ तो इट्स ओके, बट नाउ गोइंग फॉरवर्ड you should also remember this, that how time period of revolution can be calculated, ठीक है। हाँ, देवांशी n क्यूब बाय z स्क्वायर है, ठीक है। हाँ, you can use this now for future purposes also if you would want, ठीक है। Let me do just one more question, one last question before we close today's session. Okay, determine the frequency of revolution of electron in first orbit of hydrogen atom, ठीक है, and this is to be determined in the SI units. You will have to substitute the values also now. First, you will have to think what frequency is and can be calculated as. Then substitute the values and then get me an answer. हाँ, आपको फिगर आउट करना है तौसीफ, आप तो फिगर आउट कर सकते हो कांस्टेंट ऑफ प्रोपोर्शनैलिटी, राइट। द फॉर्मूला ऑफ टाइम पीरियड दैट वी डिराइव्ड वाज 2 पाई r अपॉन v। अब आप r का पूरा लंबा वाला फॉर्मूला डाल दो, v का वो लंबा वाला फॉर्मूला डाल दो with all those variables, and then you can get the answer of what the proportionality constant was. हाँ, multiple ways to think about it. V was proportional to z by n and r was proportional to n square by z. This is what we had studied. All right, so do we have any answers? No, answers aren't that pretty. Like 1 hertz or something like that. No, they are in fact quite difficult that way. Like they aren't really pretty numbers. तो इसमें हम लोग कैसे करेंगे? यहाँ पे आप लोग नोटिस करना, अभी जस्ट हम लोगों ने देखा that in order to complete one revolution, the time taken was t, right? So in 1 second, how many revolutions can be done? That is what is frequency of revolution is. Does everyone understand this definition? In 1 second, how many revolutions is the electron going to do? That is what we are supposed to determine. And we just spoke about that 1 revolution में t time period लग रहा है. So frequency is inversely proportional to time period, and this is something which you would have studied in your junior classes also. And time period was 2 pi r by b, right? So what you get is that frequency will be proportional to, और in fact इसमें value निकालनी है, तो इसमें let me not put the proportionality, let me actually substitute the values over here. V is 2.16 into 10 raised to the power of 6 into z by n, right? Meter per second, ये SI units में रहेगा, and 2 into pi को I will put as 3.14, and radius कितना होता था? 0.529 into n square by z into एंगस्ट्रॉम में है ये, तो एंगस्ट्रॉम को मैंने मीटर्स में कन्वर्ट कर दिया, 10 raised to the power of -10 meters, right? And now I substitute the values that put z is equal to 1 and n is equal to 1, because we are discussing the first orbit of hydrogen, and then you do the calculation to get your final answer. ठीक है, कितना आ जाएगा ये? 2.16 upon 2 into 3.14 into 0.529, and this will be ऊपर 10 raised to the power of 16 hertz. Like this 10 and 6 I combined up, and now you substitute these values. ठीक है, थोड़ा सा ट्रिकी कैलकुलेशन है, but still doable. So you kind of get this to be around 6.5, ठीक है, around 6.5 into 10 raised to the power of 15 hertz. So the electron is revolving really fast around the nucleus. ठीक है, all right. So आज के लिए इतना काफी है guys. I think we have come across towards the end of the lecture. Next class में हम लोग यहाँ से energy का भी discussion करेंगे. ठीक है, so I wasn't able to complete the energy bit. We were able to discuss the first two results, the radius and speed. Next class में I will elaborate on this energy part as well. ठीक है, all right guys, take care. हाँ, किसी को कुछ doubt है? Right, Aryan, you had raised your hand.
So I understood what you did over here, but I had one doubt that you said time period is directly proportional to n cube by z square. So technically time period is 1 upon frequency. So frequency would be directly proportional to z square upon n cube.
Right.
So by that answer, I got 1. So how is that wrong?
But proportionality tha na. What about the proportionality constant?
Okay, yeah, okay, fine.
That is where I use this and substituted all the proportionality constants also to get the actual answer. ठीक है, ये proportionality वाला concept कब useful रहता है? When you have to compare.
Ratio certain. Yeah.
हाँ, जब आपको रेशियो लेना रहेगा, लाइक ये दिया हुआ है वो पूछा है, तो फटाफट डिवाइड कर दो, प्रोपोर्शनलिटी कांस्टेंट्स कैंसिल आउट हो जाएंगे एंड देन योर कैलकुलेशन विल बिकम मच सिंपलर.
Okay. Thank you, sir.
बोलो देवांशी.
Yes, sir. So, sir, what Aryan said is using this the directly proportional way. So, when there's comparison, we can use that formula, right? Z square upon n cube. Frequency is directly proportional.
Right.
Yeah.
हाँ, बोलो प्रकाश.
So can we say that 6.5 into 10 raised to 16 is the proportionality constant for frequency?
हाँ, in this case, yeah, it would come out to be that.
Okay,
Because
sir.
Z and N सब 1 है ना यहाँ पर.
Yes, sir. Yes, sir.
Correct.
Yes, sir. Sir, and can you solve the 58th sum of the FPO?
58 sum of FBO कौन सा था ये? अच्छा, that was the part of the homework that I had given you. मैं
Yes, sir.
भेजता हूँ ना आपको solutions. I have the solutions with me. I'll send them.
Okay, sir. Okay, sir. Thank you, sir.
ठीक. हाँ, Gaurav, you wanted to say something?
Sir, I wanted to ask something.
Uh-huh.
Sir, when it is not related to the mathematical calculation, it's about the previous energy related question. Sir, when you said about excitation and de-excitation, there must be like a minimum wavelength as we had for photoelectric effect, that there was a minimum threshold frequency for the electron to emit from the atom. Sir, so here there should be kind of a threshold frequency, or we can say some particular frequency where it will jump from one orbit to another, right? So like the minimum frequency it
Right, right. So we
requires.
are going to in fact discuss that. We are going to discuss that in this next topic. एक बार मैं आपको एनर्जी का समझा दूंगा ना, उसके बाद जब हम ये एटॉमिक स्पेक्ट्रम पढ़ेंगे, उसमें एग्जैक्टली हम लोग यही डिस्कस करने जाएंगे. What you had spoken about.
Okay, sir. Sir, also during the jump and the the jump and like the excitation and de-excitation, it's the process is instantaneous, right? Or is
Yeah,
it taking time?
So,
almost instantaneous.
Okay, sir.
In the beginning of the lecture,
पूरा तौसीफ.
yes, sir. So, in the beginning of the lecture, you said that if the frequency of if the energy of the photon is in like 100, if 100 hertz is required to change the orbit, and 110 hertz is required, then the photon will not jump. So with
Electron will not jump.
yes, sir. The electron will not jump. So will this happen that the 110 hertz is excess? So the electron jumps, but goes past its allowed next orbit, and so below, and so it hangs out in vacuum, and and as soon as it gets excited, it comes back. So we think that no jump has happened, but the electron actually jumped, but missed its target shell. So does this happen?
No, so I will tell you that why this doesn't happen when we are going to study the atomic spectrum experiment. So usme what we will understand is, let's say you throw in all the frequencies
Yes, sir.
over the sample that you have.
Yes, sir.
Now only particular frequencies
Yes, sir.
are going to be coming out with appropriate intensities, and there will be some frequencies that will be missing.
Okay.
So that is something which will help you clear this doubt. But उसमें मुझे थोड़ा time लगेगा because I will need to explain this concept of what is spectrum first. So
But
keep your doubt handy
yes, sir.
because it's a good doubt to help understand absorption spectrum. So I will be talking about emission spectrum and absorption spectrum. So your answer will get clarified when we'll be discussing that absorption spectrum part.
Sir, so it does not happen that it goes past its target cell and then comes back.
No, it doesn't happen that way. I'll talk about it.
Okay, sir. Thank you.
हाँ, बोलो गौरव.
Sir, last thing you said something about the spectrum right now. Sir, is the spectrum continuous or discontinuous? Like, is it in bands or is it as a continuous like the electromagnetic spectrum?
It is something which will be discrete,
Okay.
discontinuous.
Sir, is it because there is like particular energy associated with each energy level, so the
Right.
difference is equal?
Right.
Not equal, but different.
Right.
Okay, sir. Thank you.
ठीक है. Any other doubt? Devanshu, you have still your hand raised.
No, sir, I forgot to lower it.
No worries. All right, chalo. Then take care, guys. I'll ask you to do some questions based on this. I'll send the homework on the group and keep you guys posted over there. Till then, take care. Thank you.